The last example we left it last time, this one, example 2. Here. This is from 5.2. So I have a tree. It makes a shadow like with distance 532 feet long. The question is, find the height of the tree if the angle of the elevation of the sun is 30 degrees. Okay, so starting for this question, we have to graph like a tree. So this is my tree here. It's the tree here. Okay, so this tree, it makes a shadow like for distance 532, like this, like around here. This is the shadow here. Here. So the distance here like 532 feet until here. Okay, and the shadow it's made by the sun, by the sun ray. So I have a sun here. It has a ray like this and makes like that. The angle of the sun ray is 30, so this angle is 30. This angle is 30. Here, this is 30 degree. The question is find the find the height of the tree. The question is, what is the height for this tree? X. So how can I start thinking for this question? Any idea? By using the previous section?
You have
How
to
can
find
I
the other
start?
measurement of the triangle.
By using which one? Triangle? Yeah, exactly. So like which ratio I have to use here, do you think?
Isn't it sine?
Which one?
Is it tan?
The tan. Yes, we can use the tan, exactly. So here I can like, if we look into the graph, these things here look like a triangle. This triangle has degree, has acute angle is 30, has this side, the opposite, the adjacent side for the 30 is 532 feet, and the question is find the opposite of this triangle. So I can like graph a triangle like this. So this will be like, look like a triangle like this. The length of the tree is the opposite side, and the sun rays is here, makes an angle here is 30 degree, and the shadow is 532. The question is find the opposite length from this point to this point of this angle. So I can like, someone of you said I can use the tan ratio. So the tan ratio of 30 is equal the opposite over the adjacent. So equal x over 532. What is the tan of 30? What is the tan of 30? What is the tan? So I know the sine of 30. The sine of 30 is 1/2 over, like we don't have to memorize the tan, so you can use the tan of 30 is the same as sine of 30 over cosine of 30. So the sine of 30 is 1/2, and the cosine of 30 is the square root of 3 over 2. So the tan of 30 is 1 over square root of 3. So this is 1 over square root of 3 equal x over 532. Now, how can I find the value for x? What is
Cross
the value?
multiply.
What is that?
Cross multiply.
Yes, you cross multiply. So I multiply the one by these things, the x with this one, and I have to try to find the value for x. So now I get 532 times 1 is 532 equal x times the radical for 3 is radical of 3 times x. Now I have to find the value for x. I have to divide both sides by square root of 3 and here square root of 3. Let me choose different color to show. So here I divided by square root of 3, here divided by square root of 3. So now I get x equal the length of the tree is 532 over square root of 3. This is the length of the tree. Okay, any question? So right now I can also find any length by using the shadow and using the sun ray for any building or any for any building or any tree by using the ratios of the tree geometry. Any question? Is it clear? Okay, so by this example we finish section 6.2. Now let's go to the 6.3. 5.3. So 5.3 talking about the trigonometric function of angles. So here 5.3. Now, what is the difference between this one and the other section for the previous section? For the previous section, for 5.2, talking about the ratio for like acute angle only. Acute angle is the angle between 0 and pi over 2. But in this section, we're going to talk about to find the ratios for any angle from 0 to 360. First of all, let me graph the angles. So if I have like the Cartesian plane like this, let me write it here. This is my Cartesian plane. So, and I have angle in the standard position. I mean, in the standard position, the initial side, it's starting at the positive x-axis, like this. And the terminal side and the the vertex is the 0, 0, the origin. So first of all, I have to know this angle here. If I start from here and the other one, my initial side, it's in the positive x-axis, and also in the terminal side, it's in the x-axis, the angle will be 0 degree, and the same thing's 0 radian. If the angle it's in the like this here, I have to know, starting from here to here, the angle here is pi over 2, and it's the same as 90 degree. We have to know also this angle here, starting from the initial side, it's the positive x-axis, like this. The angle here is pi, and this is the same as 180 degree. Also, this angle here, different color, green, this is starting from the initial side, turn around like this. This is pi over 2, and this is the same as 270 degree. By 3 pi over 2, I mean 3 pi over 2, same like 270 degree. And the last one, if turn around from here around until here, like this, so the angle will be like 302 pi. Starting from here, turn around, this is 2 pi, and it's the same as 360. So the angle at the positive is 0. So you have to know this is 0, this is pi over 2, this is 3 pi, and this is 3 pi over 2, and this is 2 pi. And the same things for the small angles. So here I can set the other one. So again, let me show you again. So here, 1, 2, 3, 4, 5. Starting from 0, always starting from 0, starting from 0, starting from 0, starting from 0. So the first one here is 0, 0. Here, like this, like this, and go back again. So here's 0 degree, and the same thing, 0 radian. Here is the angle is pi over 2, 90 degree. Here is pi equal 180. Pi over 2 is equal to 170. Starting from here, like this. Starting from here, like this, is 2 pi over 360. Okay, so this is you have to know. Also, there is another angle like this. Uh, 1, 2, 1, 2, 3. First one is look like this. Second one up. Third one like this. So this angle here, from all of them starting from the positive x-axis, this one is pi over 6, and pi over 6 is equal 30 degree. This is pi over 2, or pi over 4 is 45 degree, 45 degree. And this is pi over 3 and is the same as 60 degree. Okay, so by these things, we're going to use it during this section. First things we have to go over is the trigonometric function of angles. So I'm going to define it. Here. Any question for the angles? Is it clear? The previous graphs here. Any question for this? Just you have to memorize, you know, this is the 0 angle, this is 90, this is 180, 180, 270, 360. And you have to know the small angle, acute angle, 30, 45, 60. Now, trigonometric function of angles. So first of all, we have to know if I have angles in the look like this graph here. Such that it has triangle like this. So again, this is the x-axis and this is the y-axis. This triangle has length from this point is the origin, O, 0, 0. This point is the Q point. This point is called by B of x comma y. Here, this angle is theta. This length from here, from B to Q is y. The length from O to Q is x. And the length here, by using the Pythagorean theorem, is r equal square root of x squared plus y squared, by using the Pythagorean theorem. Okay, so first of all, I can define the sine function. The sine of theta of this angle is equal the opposite over the hypotenuse, y over r. Also, the reciprocal for the sine is called cosecant of theta is equal r over y, such that y here is not equal 0. This is not equal 0, the y. Second things, here we have sine, cosine function. The cosine of the angle theta is equal x over r. Adjacent over the hypotenuse. The reciprocal for the cosine is 1 over cosine is called secant of theta. And the secant of theta equal r over x, such that x here not equal 0. Okay, the last one is the tan of theta. The tan of theta is equal the y over x, the opposite over adjacent. And the reciprocal for the tan is 1 over tan is called cotan of theta. And this is equal x over y. And again, the y is not equal 0. Okay, so this is together, this together, and this is together. This is the function, the trigonometric function. This is the trigonometric function. Okay, any question? Is it clear? It's look like the ratio like last time, but we're going to call it as trigonometric function because we're going to use it for any angles. The angles from 0 to 360 or 2 pi. But last time we used it only for acute angles from 0 to 2 pi over 2 for small angles. Okay. So now we're going to evaluate trigonometric function. So how can we evaluate the trigonometric function? We're going steps. Okay, so here evaluation trigonometric function for any angles. So to do that, we need only two things. The first one, we need to know what is the sign of the trigonometric function. Number one, we have to know what is the sign of the trigonometric function. I mean, for the sign, I have to know is positive or is negative. This is the first step. Second step, I have to know what is the reference. It's called the reference angle. Okay, so let me start from for the first one, the sign of any trigonometric function. So for number one, the sign here of the trigonometric function. So by using this diagram, you have to know here all the function here is positive. If the angle in the first quadrant, this means all the function are positive. For the second one, here, the only function is positive for second quadrant is the sine. If the angle is in the second quadrant, so the sine will be only positive. Now, for the third one, the only function is positive in the third one is the tan. If the angle is in the third quadrant, the tan function will be only positive. For the fourth quadrant is the cosine, is the only function is positive for this function. I mean for that, like if my angle starting always my angle starting from the position, the standard position. Standard position, like I said, is the positive x-axis, and the origin, it's with the vertex of the origin like this. Suppose my angle like that, something like this. So here the angle is in the second quadrant. So this is mean the sign only positive. The only function is positive is the sign. For the third quadrant, suppose my angle like this, starting like that, stop here, like this. The only function is positive is the tan function. Okay, how can I memorize this? So there is like a word as all student taking calculus. Okay, so I can memorize this by all, the first letter here, student S taking from the T calculus. So I can say here to memorize this, all student take calculus. Okay, so for the first function, all function are, or trigonometric function are positive, sine, tan, taking, or take calculus. Okay, so for the second one is the reference angle. So this is about the sine for the trigonometric function. Now we're going over the reference angle. So the reference angle, I'm going to define the reference angle. Number 2. So what is the mean of reference angle? Any idea for reference angle? What is the mean of reference angle? Okay, I'm going to give you the definition for reference angle. So for reference angle is acute angle formed by the terminal side of the angle and the x-axis. So here, if the is the acute angle formed by the terminal side of theta and the x-axis. I mean, for that, I give you example to explain that. Suppose for the first, second, make it more smaller, like this. First one, second one, third one, and fourth. So all of them, the angle are in the standard position. Suppose for the first one, the angle look like this. Second one, something like this. Third one, and the fourth one like this. So first of all, this is my theta. This is the angle. What is the reference here? So the reference angle is the same as theta, is between the terminal side, this is my terminal side, and the x-axis, and its acute angle, small angle. So theta is equal to my reference angle for the first quadrant. So reference angle we denote by theta bar. For the second one, my angle look like this. This is my angle. The reference angle is the acute angle between the terminal side, this is my terminal side, and the x-axis. This is my x-axis. So the acute angle is this. This is theta reference. For the third one, my angle is starting from here, turn around, stop up to here. This is my theta. What is the theta reference? Or what is the theta reference? This one is between the terminal side, this is my terminal side, and the x-axis, and its acute angle, so it will be like this. This is my theta reference. For the third one, for this one, so starting from here, turn around, this is my theta. So what is the theta reference? Is the acute angle between the terminal side and the x-axis. So this is here, theta reference. Any question? Is it clear? So I'm going to give you a table. This table, for all angles, they have the same reference. So I give you a table. Angle in the first quadrant, angle in the second quadrant, angle in the third quadrant, angle in the fourth quadrant. And the reference for these angles here is called theta bar. So this table is just for memorize. You can't use it for exam because you have to memorize it. You have to know the angle in the first quadrant. Suppose it's pi over 3. Pi over 3 and 2 pi over 3 and 4th pi over 3 and 5 pi over 3. All of them, these angles, have the same reference angle as pi over 3. This angle is in the first quadrant. This one, it's in the second quadrant. This one, it's in the third. This one, it's in the fourth quadrant. All of these angles have the same reference angle. It's pi over 3. For the second one, here, pi over 4. It's pi over 3. Here, pi over 3. So for pi over 4 and for 3 pi over 4 and for 5 pi over 4 and also for 7 pi over 4, all of them, these angles, have the same reference angle as pi over 4. Now for pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, all of these angles have the same reference angle as pi over 6. So how I know? Again, I'm going to choose pi over 3, or I'm going to choose pi over 6. So this is, for example, for pi over 6 to show you how I know this is the reference angle is pi over 6. Here the Cartesian plane, and I'm going to choose 11 pi over 6. So as I know, the 11 pi over 6 is in the fourth quadrant here. Why it's in the fourth quadrant? Because 11 pi over 6, this value here, this is a 3 pi over 2. To make the denominator over 6, I have to multiply both sides by 3. So I get 9 pi over 6. And this value here is 2 pi. And 2 pi is equal, if I want to make it the denominator over 6, so this is equal 12 pi over 6. So 11 pi over 6 is between 9 pi over 6 and 12 pi over 6. Okay, so the angle it's in the fourth quadrant, starting from here, turn around, up here. So the angle theta, this is theta 4. Why? Because it's in the fourth quadrant, 11 pi over 6. So theta 4 is equal 11 pi over 6, 11 pi over 6. Now, the reference angle is the acute angle between the terminal side and the x-axis. So it will gonna be something like this. Here, the red one. Why? Go back to this graph. This is my reference angle. This one. So here, my reference angle. So my reference angle is this. What is the value for this one? Is 12 pi over 6. I can set angle is equal 12 pi over 6 minus 11 pi over 6. And this is equal pi over 6. Like here. Like here. So the reference angle for 11 pi over 6 is pi over 6. 7 pi over 6, the same things, the same idea. It's gonna be like 11, it will be like pi over 6. So all of these angles have the same reference angle. Same things here. All this have the same reference angle. All this has the same. And you can check by one, the same idea like here. Any question for the reference angle? No questions? Okay, so now the important things, after I know the sign and I know the reference angle, I'm going to evaluate any trigonometric function. So my question now, my example, evaluate or find the value for sine of 7 pi over 6. Who will do this one? Sine by 7 pi over 6. Who will do this one? Give me the steps, I mean. Okay, no one will do this one? Okay, first of all, what is the angle? In which quadrant? 7 pi over 6. What is 7 pi over 6? In which quadrant?
On the second one?
Second one. Okay, let me check. So this is 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. make the denominator over 6. Pi over 2 is the same as multiply both sides by 3, get 3 pi over 6. The pi, multiply both sides, it's over 1 actually. Multiply both sides by 6, I get 6 pi over 6. This one, multiply both sides by 3, so I get 9 pi over 6. And the same things here over 1, multiply both sides by 6, so I get 12 pi over 6. 7 pi over 6, he said it's in the second quadrant, but the second quadrant is between 3 pi over 6 and 6 pi over 6. The 7 pi over 6 is not in the second quadrant. So it's greater than this thing's 6 pi over 6 and less than 9 pi over 6. So Joanne, he said it's in the third quadrant. That's true. So 7 pi over 6, it's in this quadrant, third one. So it's going to be something like this. This thing. So the graph, the angle will be like something like this, like that, up to here. This is 7 pi over 6. This is theta. Now, what is theta reference? So first of all, the sign here, because we have to know the sign, we need two things. Number one is the sign. Second things, we need the reference angle. So what is the sign for the sine function in the third quadrant? So for the third quadrant, the only function is positive is the tan function. The sign will be negative in the third quadrant. So the sign here will be negative. Okay, now what's the reference angle? So the reference angle is it's acute angle between the terminal side and the x-axis. It's gonna be something like this. This is my reference angle. So go back to the table, the easiest way. 7 pi over 6, this one. It has a reference angle is pi over 6. This is my reference angle. So here, the reference angle is pi over 6. Or I can calculate it. This is my reference angle. I can say reference angle is equal this everything here, 7 pi over 6 minus 6 pi over 6. Everything minus this things. Everything minus this one here. Let me, like, from here to here is 7 pi over 6 minus from here to only here is 6 pi over 6. So the answer here is pi over 6. Is the same like this. Is the same like the table. Okay, so the sign is negative and the reference is pi over 6. Now to evaluate, I said sine, use the red color is better. So the sine now, sine of 7 pi over 6 is equal negative sine, here the reference angle, pi over 6. Now this is from the last section, from previous section. What is the sine pi over 6? Where is the sine of pi over 6? We have a quiz today for this section, I think. What is the sine for pi over 6? One half, yes. So the answer is negative. The sine of pi over 6 is 1/2. And this is the answer. Is it clear? How to do the steps? Any question? Any question? Okay, for the second one, another example. Find the cosine. Find cosine of 240 degree. Yes, I'm doing another example. The cosine for 240 degree. First of all, when you see something like that, you have to graph. You have to know what is the angle in which quadrant. So, first of all, we have to know this is 0, this is pi over 2, and pi over 2 is 90 degree. This is pi and is equal 180 degree. This is 3 pi over 2, and this is equal to 170 degree. 270 degree. And the last one is 2 pi is equal 360. Where is 240? In which quadrant?
Oh, third.
Third one. Why? Because 240 is between 180 and between 270. So it's gonna be like in the third quadrant, like this. This is the first step. Now, second step, you have to find two things. Number one, the sine. Number two, the reference angle. So for the third quadrant, what's the sign for the cosine function?
Negative.
Negative. So the sign for the cosine function is negative. Why? Because going back here, the only function is positive is the tan function. Any other things, any other else is negative. So the cosine in the third quadrant is negative. The reference angle. The reference angle is the acute angle between the terminal side, this is my terminal side, and the x-axis. This is my acute angle. This is the reference angle. So what's the value for the reference angle? Here I can calculate it. Is the measure between these things and the x-axis. What is the value? Who will do it? What is the reference here? The same idea like here. The reference is we subtract the value here, 7 pi over 6, minus 6 pi over 6, minus this, like this, minus this. We find this one, the reference. Now here, what's the value for this red one, for the angle? So I know
7
my
pi
angle
over
is
6.
240. What is it?
7 pi over 6.
7 pi over 6. Can you do it in the with degree? Because my question is here by degree. I think here it's right. I don't know exactly, but I'm going to do it by degree. So the angle from this point to my terminal side is 240. 240 minus, from here, from this point to this point, like this, is 180, minus 180. And the answer is 2060. 60 is, the 60 degree is by radian, it is pi over 3, is not this. This is the degree, this is the angle. I think this is equal 7 pi over 6. Then you solve it by the radian. But I'm here doing by degree. I'm not going to use these things. So it's equal 60, and 60 is pi over 3. So now, after I find the reference and I know the sign, I can solve this one. So I can set cosine of 240 degree is equal, the sign is negative, cosine of the reference, 60. Now, by using the table from previous class, what is the cosine of 60? What is the cosine of 60?
One over 2.
It's, what is it? 1
over 2.
1 over 2? Yes, so yeah, so it's 1/2. So it's equal negative 1 over 2, or 1/2. So this is my answer. This is the value for cosine 240. Any question? Is it clear? Is it clear how to find the value for the cosine function? Okay, so let me give you another example. One more example. So the question is, find the secant for minus pi over 2 over 4. What is the secant function? What is the secant? The reciprocal for which one function?
Or cos.
Secant for reciprocal for which function? This one,
Cosine.
cosine. So the secant is equal actually 1 over cosine. So the secant here, this is equal 1 over cosine of minus pi over 4. Now we have to graph to know what is the angle exactly in which quadrant. Graph something like this. Okay, so minus pi over 4, we're starting from the positive x-axis. We go around this one in clockwise, like this. Why? Because negative. So that's why the negative means the direction. We're starting like this, clockwise. So negative pi over 4 is acute angle. Since here we have to know this is 0, this is negative pi over 2, this is negative pi, this is negative 3 pi over 2. And if we go back here again, is negative 2 pi. This is negative 2 pi. Now, if I'm going to make the denominator over 4, I have to multiply both sides by 4. So this is equal negative 2 pi over 4. This is equal negative 4 pi over 4. And same things here, it is equal negative 6 pi over 4. And this is here equal negative 8 pi over 4. So negative pi over 4 is between the 0 and between the negative 2 pi over 4. So the angle will be in this quadrant, this one here. Why? Again, because negative pi over 4 is between the 0 and the negative 2 pi over 4. So this is my angle here. This is theta equal negative pi over 4. So I need two things. Again, the sine reference angle. What is the sign for the cosine function in the fourth quadrant? All students take calculus. What is the sign
Positive?
for cosine function?
It'll be
Positive. Yes, will be positive. Now, what is the reference angle? So the reference angle, again, it's the angle between the terminal side and the positive x with the x-axis. It's acute angle. So this is acute angle between the x-axis and the terminal side. So the value for this one is the same as this one, but without the minus, because the reference angle is always positive. So it's the absolute value for pi over 4, negative pi over 4. Because the reference angle is always positive. So it's gonna be like pi over 4. Now we have to solve it. So secant of minus pi over 4 is equal 1 over cosine minus pi over 4. Now this is equal 1. The sign for the cosine is positive. Cosine. And the reference is pi over 4. This is equal 1 over, what's the cosine of pi over 4? Cosine pi over 4 from the table. It is, what is it? From the table, it's square root of 2 over 2. And 1 over these things is equal 2 over square root of 2. We make the denominator without fraction, we just multiply by square root of over 2, multiply by square root of 2, and this give me 2 square root of 2 over 2. We can cancel this by this, and the answer is square root of 2. So the value for the secant minus pi over 4 is square root of 2. Any question? Any question? No questions? So the main idea is to find the sine, and then you have to find the reference. How can I know? By graphing the angle. Okay. Any question? Okay. So now the fundamental identities. Fundamental identities. So we have two kind of identities. The first one is the reciprocal identity, and the second one is the Pythagorean identity. So reciprocal identity is like here. First one for the reciprocal identity is the cosecant of theta is equal cosecant of theta is equal 1 over sine of theta. Number one is secant of theta is equal 1 over cosine of theta, and cotan of theta is the same as 1 over tan of theta. Also, I can set 1 over tan is the same as cosine of theta over sine of theta, and the last one is the tan of theta is sine of theta over cosine theta. This is called the reciprocal identity. The second identity is called the Pythagorean identity. So the Pythagorean identity is this. We have three only Pythagorean identity. First one is sine square plus of theta plus cosine square of theta equal 1. Number two, put here, tan square of theta plus 1 is the same as secant square. Third one, the 1 plus cotan square of theta is the same as cosecant square of theta. Any question? Is it clear? Do you have any question for this, the identity? You have to memorize this identity. So we're going to use this identity for the example below. So the example, evaluate a trigonometric function. So first one, if the tan angle, the tan of the theta is equal 2/3, and theta is in the third quadrant. Quadrant 3. Find the cosine. The question is find cosine theta. How can you evaluate the cosine theta? By using the tan of theta. And theta here is in the third quadrant. Any idea? Okay. So I have the tan angle, the tan of the theta is 2/3, and my theta is in the third quadrant. The question is find the cosine of theta. So in the third quadrant, what is the sign of the cosine function?
Negative.
Is negative. So first of all, I have to set the sign for the cosine function is negative. Why? Because the theta is in the third quadrant. Second thing is to solve this thing, you have to graph like a triangle like this, and in this triangle you have to use it for the tan of the angle. So my angle is theta, so this is my theta. The tan of the theta is 2/3. This is mean the tan of theta is 2/3, and this is equal the opposite
Adjacent.
over the adjacent. So this is equal here from this one, from this side to this side is 2, and from this one to this one is 3. Now to find the cosine, I need the hypotenuse. I need the distance from here, from this point to this point. So to find the distance from this point to this point, I have to use the Pythagorean theorem. So Pythagorean theorem said, I said this value is x, for example. So the value for x square equal 2 square plus 3 square. The 2 square is 4 plus 3 square is 9, and it's equal 113. To find the value for x, we have to take the reciprocal for both sides, so I get x equal the reciprocal of 13 is only the positive. I don't have to use the negative. Why? Because always the length is positive. So the value for x is the square root of 13. Now, the question is find the cosine of theta. So the cosine of theta by using the triangle is the opposite over hypotenuse. So it's equal opposite over hypotenuse. And this is equal 2 over square root of 13. But you have to use this. The angle is in the third quadrant. So the sign of the cosine here is negative. So it's going to be negative 2 over 13. This is the answer. Any question? Any question for this example?
Isn't cosine adjacent over hypotenuse?
The cosine is
opposite
oh,
of
okay. Yeah, sorry. Okay. So the cosine is adjacent over, so here adjacent over hypotenuse. So the adjacent is 3. So 3 over the square root of 13. Thank you. And don't forget the minus because it's in the third quadrant. So in the third quadrant, the tan is only positive. The tan only positive. So for the third quadrant should be negative 3 over square root of 13. Any question? Okay, let me give you another example. So the example now, if the secant of theta equal to, and theta is in quadrant 4. The question is find the sine of theta. So same idea. The secant here of theta is equal to, what is the secant? Secant of theta. What is the secant?
Hypotenuse over opposite.
Opposite of what? Okay. Can you use it by triangle function? The reciprocal for which function?
Oh, yeah.
1 over cosine.
The secant, this one, reciprocal, is 1 over cosine. So the secant is the reciprocal of cosine. So secant of theta is 1 over cosine of theta. And this is equal to, so I can find the value for cosine. How? Because this is equal 1, can I do cross multiply? So this is equal like this, 2 times cosine of theta equal 1. So cosine of theta equal 1/2. I divide both sides by 2. This by 2, this by 2. So the cosine of theta is 1/2. Now I have to do triangle. This is my triangle here. This. So the angle is here. I have the cosine of theta is 1/2, is opposite, adjacent over hypotenuse. So this is my equal 1 from here to here, and from here to here is 2. Now we have to find the value for this x. Again, by using the Categorian Theorem. So 1 square plus x square equal 2 square. Simplify this one, so I get x square, subtract the 1 from both sides, get, let me do it step by step. So this is equal 1 plus x square equal 4. Subtract the 1 from both sides, get x square equal 3. Take the square root for the both sides, x equal square root of 3. We choose the positive because always the length positive. So this is square root of 3. The question is, find the sine. You have to know the sine of the sine function in the fourth quadrant. Sine of the sine theta in the fourth quadrant. What is the sine in the fourth quadrant? The sine of the sine function in the fourth quadrant is negative. How I know? From here. Again, the only function is positive in the fourth quadrant is the cosine. Is negative. Second things, go back to the graph. So sine of theta equal opposite over hypotenuse. What is the opposite? Square root of 3 over hypotenuse is 2. And don't have to forget the minus. So the minus of this. This is the answer. The sine of the fourth quadrant is negative. It's not positive. Because the cosine is positive, so the sine will be negative. Okay, so here the last things in this section is the area, how to find the area of triangle. Any question for this example? Okay, so now area of triangle. So now I have to find the area for any triangle by using this formula. The formula is direct. So the area is denoted by like this, reciprocal of A of triangle with length is A and B with include angle theta is given by the reciprocal of A equal 1/2 times A times B sine of theta. Okay. So this is the area for any triangle. So let me give you example. Find the area of the following triangle. So suppose my triangle is something like this. Okay, this angle is 120. This is 3 centimeter, and this is 10 centimeter. The question is find the area of this triangle. I need to find the area for this triangle. So to find the area, I have to use the formula above. It said reciprocal A equal 1/2 times A times B sine the angle. So my A is 3, B is 10, and the angle is 120. Just to plug it inside this formula, so I get A reciprocal equal 1/2 times 3 times 10 times sine of 120. Now the same things like before. What is the sine of 120? So we have to find the sign, positive or negative, and we have to know the reference of the 120. So we're going to do it in the back. So okay. So sine of 120 is sine 20. So 120 is in the second quadrant, like this. Why it's in the second quadrant? Because it's between 0 and 180. Between 90 and 180. This is 90. So the 120 is like this. 120. So the sign here will be positive in the second quadrant. The sign is positive in the second quadrant. The reference, what is the reference? What is the reference angle? What is it?
60 degrees.
I can't hear you. What you said?
60.
50? 50?
Is it 60?
60. Yes, it's 60. That's true. Because here we have 180 and the reference angle is the acute angle between the terminal side and the x-axis. This is my reference angle. So to find the reference angle is equal everything 180 minus 120. And the answer is 60. This is my reference angle. So to find the sine of 180, 120 is equal sine of 120 equal positive sine of 60. What is the sine of 60? From the table, sine of 60 is square root of 3 over 2. So the answer is square root of 3 over 2. Okay. So the value here is the square root of 4 over 2. So let me continue. So 1/2 times 3 times 10 is 30 over 2 times this one is from here square root of 3 over 2. Square root of 3 over 2. And the value is 15 square root of 3 over 2. This is the answer. Any question for this? Okay, so the section is finished by here.
Wait, how did you get 15? I'm sorry. It wasn't like.
It's where here, this one?
Yeah, sorry.
Because 30 over 2 is 15. Okay,
Oh,
let me do it
got
here.
it. Sorry.
So this 15 times this things. So 30 over 2 is 15 times this thing is 15 square root of 3 over 2. So here, this one is 15. Okay. So 5 minutes left. Let me just give you interview for 5.4 and next
Can
time
you
we're
go
going
back
to do it. Yes,
one slide back?
yes. Yeah, sure.
Thank you.
No problem. So the quiz at 7:40. The quiz at 7:40. So we have 5 minutes. Yes, for 15 minutes. The quiz for 15 minutes, yes. You finished for this one?
Yes.
Okay. So small interview for the next section is 5.4 is the inverse triangle. Trigonometric. So just you have to know the sine inverse of x equal y. This is equivalent to sine of y equal x. Cosine inverse of x equal y is equivalent to cosine of this value y equal x, and the tan inverse of x equal y, this is equivalent to set tan of y, this y, tan y equal x. This is the first things you have to know. And second things you have to know the function and the domain and the range. And so I'm going to make a table, small table. Here the function. Here's the domain. Here's the range. The function is the sine inverse of x, or of the any angle, tan inverse and cosine inverse. So the sine inverse has the domain from -1 to 1. The tan is from -1 to 1. I mean, for all real numbers. And for the range here, we have from minus pi over 2 to pi over 2. And the same things here, from minus pi over 2 to pi over 2. But here, open parentheses, here, closing parentheses. For the cosine, the domain is the same as the sine inverse. And for the range is from 0 to pi over 2. So we're going to stop up to here today for this table. Get ready for this table for next time, because we're gonna give you example right away for these things and explain for the inverse.
Could
Okay,
you show this next quiz? Because I didn't have time to write it down. So can you just show it at the beginning of the next one? I mean, of the next class, I'm sorry, not quiz.
For what exactly? To show you this?
Yeah, I just want to write it down, that's all.
Yeah, sure. Yeah, sure. No problem. Okay. We stop up to here today, and I see you next week.